No, cool. So today's video, the date is now 16th of February 2026. The time now is 1:59 a.m. precisely. Go to two. So let's do this video right now, right here. So this video basically is on Lapis calculus. Yes, Lapis, correctly spelled by the AI system. So, so I'm gonna write a form. So, basically it's calculus with power. I call it power calculus. Basically, dual calculus module, dual calculus. So basically, you have basically how it's sort of formed is dual calculus. You're gonna have dual calculus. So you can use it for two things. Dual calculus is like if you guys get this, like you say, so you're gonna have a backwards six, a backwards, the kind of the like a six, but it's backwards. You're gonna have two of them, and that's equal to one system. This is gonna be 2 units, any 2 units, like 2 to the power to any 2 units, any 2 integration to the power of it's going to root to one, two to one mapping. So it's a 2 to 1 ratio of any system, anything is a unit, everything is unit. But that's the two formula, but anything 2 to 1 doesn't really make any sense. But this is Lapis. So Lapis is spelled. One second, guys. Alpha llama, alpha llama, alpha llama, A for apple, P for papa, I for indigo, I for Sarah, those Lapis calculus. We're gonna have a June. We're gonna do some working out today. So it's a 2 to 1 mapping. Everything is mapped to 2 to 1. So basically, the back you get like a right hand. You get 6. I don't know what the symbol is called, but it's like a symbol in Greek. So basically, you get 2 back 6, which Lapis to 1 4 6. But 1 6, one right 56. So 2 left is 1 6. Basically, the 2 left 6 are called Lapis notation. So the 2 left are called Lapis. So you're gonna have 1 full half Lapis, which 1 full Lapis, 1 full 6 to half system. So it indicates half of the other system on the other side. So basically, one full, so you get 1/2. You get 2 1/2, 2 sets of 2 pairs of 1/2. You can add up, you can accumulate in partial system. Think of them as derivatives and integrals. So you're gonna have one dual integration, which is 1/6 to and 1 dual integration and 2 derivatives. So you can have 2 disjoint derivatives. So the derivatives are basically have to have into one position. Because the Lapis is about integrals, it's not about derivatives, but it's calculus. So, for example, let me give you a problem. So, formally, a problem can be in 2 states. One, obviously, it's a shared problem. So, you have my OB negative differentiation system. So, if you have, basically, you have 3x squared minus 6 y plus 2 equals 13. Now, you want to integrate, so you want to derive and integrate over an x term. So you're gonna have the standard way of doing it. You're gonna have the OB distribution system. So that base works on basically an angle of pi over 4. Basically, works on pi over 4, pi over 3, pi over 2, and pi over 1, and pi over 1. But you're gonna have a system of derivatives. So even about OB the derivative relation system. If I want to find the value of x and y, of y, x in y, or x of y, you have 2 ways. So because you have the integrals, you have x in y. So because you're gonna have derivative of x in y, you're gonna have x of y. So that's really the 2 truths. One lapis, one backward 6. I don't know what the symbol is. The formal mirror symbol is. It's basically 2 derivatives. So you can have 2 derivatives in here. You can take, So basically, you're going to have some power. So you have power and you have value. Power basically is literal power. The measurement of power in the system. Energy in the system. But energy is called power. So power equation equals force times work. Power equals force times work. And work equals force times displacement. So you can have a derivative of work in the binary. Basically, you measure 2 systems in once, and you get one solution. But you're gonna have an angle of 360, 360 rotation, 0 to 180 for a path, 0 to 180 degrees for a path, and which is halfway between part of 180 between 180 divided by 180 is one half of A and B. A and B. But this is the power of this kind of engine. If you can't even do 180 divided by 2, you have 1 divided by 2, you have 90 degrees. 90 degrees is basically the zero power, a shared power, so power between just 90 degrees is an angle. So the Lapis just works on kind of the theta notation of theta equals tan to the power of -1 b divided by a. But b is basically a point b and a is equals to point a. So this integration, what the calculator. Um, uh, this equals to I'm going to so I'm going to work it here on the board, the problem, but let me propose a problem. So you're going to have this work two systems at once, but the system is coherent enough to work together. So I have a calculator here. Let's work on out, one from out. So it's comprehensive to understand that Lapis is basically two derivatives. Every one integration has one Lapis. Every two integration has half. So you're gonna have one half ratio to every two. You're gonna have a half and half is one integration. But two derivatives equals one integration. One integration like one integration space. So for example, let's take the derivative of this of x and y. Given x squared plus minus 6y plus 2 equals 13. So you're gonna have that there. So let's do this. You're gonna have let's look at one side. You're gonna have x squared minus 6y minus 2 here, or 0 equals minus 2. 12, 11 equals 11. So minus 2, 11, 12, 13. Then you have x squared. So x squared is what? X squared is basically if you derive over x squared, if you just get the root of x squared. If you just get sign x. Let's find x integral. The integral of x is basically times by the power. No, so the derivative is going to times the power. Times the power and minus one from the minus one from the power and times by the old power. And that's the derivative taken. So you get a minus 1 for the power and times the power. So basically, minus 1 for the power is x squared minus 2 minus 1 is 1 x. So x equals x. Minus 1 for the power. And so x minus 6. So basically, the derivative of this equation, let's call it u. Derivative of u unit x x minus 1 minus 6 minus 1 for the power. Minus 1 for the power is 6y minus 6y. 6y. Basically, you have to have 6y. No, I have to put it on the other side. So you're gonna have change. So d1 equals derivative of u prime is x minus 6y 6 to the power minus 1 for the power 6 power 0 minus 1 is 0 y minus 1 is 0 is minus 6 6 1 for the power 6 times 1 is minus 6. So minus 6 equals 11. So this is the concept. This is a change at derivative 1. So we have the integration of derivative 1. So this is basically one solution to the problem over this is basically one solution space. The solution space is x minus 6 equals 11. But this if I add plus 6 here, I have 17. So x equals 17 here. But this is basically the resistance system. Now I have in one system the third derivative. Now go to x minus plus x equals 17. X equals 17. So x equals 7 plus x minus 6 equals 11. Now you have the other one. So the other one will be the integration. So if I have the integration, then I have opposites. So if I have if I'm like if I have to flip this, you have to do minus 1 to the power times by the old power. So you gotta divide by the old power and minus add 1 to the power. So basically, you divide by the root power, and you have to flip it, so divide by the root power. You just take an error, so dividing by the root power is taking an error. So you're going to have x squared plus 6 squared. You're going to have x equals to 17, but the integration will be, x squared, you're going to have x squared minus 6. You're going to have divided by the whole power. X divided by 2, square root of x. So the square root of x, square root of x, this is the integration. No, this is integration would be kind of f. Integration of equation of this system over one over the unit of 180. So this is 180 because it's over 180 degrees. Is x because it's the pathway. So basically, you get 0 to 180 because it's not 90 degrees, but you have a 90 degree shared state. So you're gonna have something there. So basically, x squared x square root of x square root of x will be divided by 2, divided by the power 2. So square root of x, basically, no, basically, I have this one there. So I have to start from scratch. So you're going to have from the 18. You're going to start from this. You're going to write my solution down for the first one. Because I don't want to make a mistake here. So my solution was for the first one, my solution was x plus x equals 17. So basically, the problem was x squared minus 6y plus 2 equals 13. So if I do this properly, let me see down here. I'll show you how it works. So basically, it was a polar axis. Polar axis. You're gonna have, first you're gonna have x squared. So divided by the power, divided by 2. So the square root of x. The square root of x minus 1 plus 1 to the power square root of x cubed. No, wait. Um, no. Sorry, I got it wrong. This gets smaller. So we're going to get integration. So you're gonna get times the power minus by times that 1 10 to the power by 1 times the power minus the power divided by the power divided by the power add 1 times the power minus times 1 by the power times 1 by I just remember how to do it because I didn't know how to do times 1 by the power okay minus the power minus the power minus 1 to the power times by the whole power. So this is what it is. So I took minus 1 to the whole power, minus 1 and 10 to the whole power. So I have to add 1 to the whole power and minus divided by 1. So basically, so I'm going to. So I have to add 1 to the whole power. So basically, that would be 2 plus 1 equals 3. X to the power of 3 is the first step. You have to add 1 and divide. By the old power divided by 2. So basically, it's square root of 3 divided by 2, and that's the equation of the system plus or minus. No, basically, I have to do it on the side, so I didn't get it right. So let's go good. So get my solution here. I'm doing it wrong here. So I'm doing here. So on paper. So again, I'm doing it on paper. So I'm gonna do equals 30. So minus 2 will give you 11. 11 we get x squared minus 6y equals 11, and then we get this integration stage. So we have to do this stage. So we're gonna have x cubed divided by 2, and that will be 6. And then we're gonna do add 1 to the power y to the power of 2 divided by 1 minus 6y divided by 1 equals 11. So so you're gonna have this kind of equation, but this basically spans 180. So 180 degrees, and so the equation is the integral of the system over a solution of path A to B 180 degrees lies in space of s cubed over 2 minus 6y squared squared what over over 1 over 2 divided by 1 is 1. So 2 divided by 1 is 2. Minus 6 equals 11. So 11 will be 6 plus 2. But there's a solution here. You map for every pathway, shape, or form. So you can understand that s cubed to the power of 2 is 3 divided by 2 is a rational source. So basically, 3 divided by 2, basically 3 divided by 2 is 3 minus 2. So this different equation. So the x squared minus 6y plus 2 equals 13 and equals 11. What is share 11? Share 11. X equals 7. X equals 17. But what is the area of x and y? This is the area of x and y is given by the power. By the power. So you're gonna try to define the power. So the power literally means what? So basically you're going to have some kind of reducing system in the kind of framework of the lambda calculus. You got alpha energy and got beta energy, but you're gonna have to tell me what how much energy because beta energy usually is a subset of the system. Basically, the kind of thing you're gonna understand is alpha and beta are isomorphic properties. If you don't know what I mean, think of the equation uh, minus b plus or minus square root of b squared minus 4ac. So this over 2a. So this b squared minus 4 is equal to discriminant. Um, discriminant. Yeah, yeah. So if you don't take the square root, you're gonna have this falling to minus 1, 0, or 1. Based on how it hits the line. The discriminant determines the root of the system. So basically, this is one. This formula, this b a squared, b squared. Sorry, b squared minus 4ac is the determines the kind of a system of discriminant. So basically, it determines the root of the polynomial. What do you do? Cross the line, one, don't cross the line, minus one, or lie, or choose, or has a infinite solution space to the problem. Basically, they don't. They have 2 points to cross. Do they cross the point? Basically, if b squared minus 4ac equals one. It is one. Is one. Is one. That means they cross the y axis. The cross y axis. The two lines. The cross of the if the zero, that means they don't cross. They touch. They touch. And if they're minus one, they never cross. Never cross. But what is the tangent? Zero means it's a tangent line. So you understand that this is lambda calculus too, but it's a Lapis equation. So you're gonna have this model of discriminant. So for this equation, you're looking at for the integral here, you're looking at x cubed divided by two. 6 minus 6 x cubed. Is there a formulation? Is there a uniform calculus? This is basically called alpha. So basically, this is called beta alpha. So the discriminant here of my if you're using y equals this is basically determining y. The discriminant determines y. This is alpha. So alpha refers to alpha energy. So the alpha means the basically you have to compute over the system. This is the hardest thing to compute, but you use more solutions. If you're trying to use if you use your source, you can match this up into no matter how you part you take, you can have this formula form a system of non-linearity, and basically y equals basically in this case, in my case. The alpha is what the share, which is a quadratic polynomial. So I could just solve this quadratic polynomial. A quadratic polynomial with like s squared term. S squared term. I identify it from as a quadratic polynomial because the s squared, the share is one y squared. But if you have two functions, if you have two quadratic polynomials, and you don't know that they're quadratic, this system can detectify you, and you can have a tracing of the pathway. Basically, you can take a derivative and take a derivative, take an integral, and find out how they over the Lapis framework. So you can understand that taking two integrations allows you to see a clear picture of the full picture of the system because they are tomographic. They work in halves. So you can understand the two derivative equals one integration, one Lapis integration. Two derivative equals two natural derivative equals one big derivative. Two integration equals one Lapis integration. But that's two sets of derivatives and two sets of integration. I think I did it wrong. Yeah, I did it wrong. So you understand, you have to derive twice. So I didn't derive twice, guys. So let me try to derive twice now. Because it's kind of new framework, so I have to do it right. So you can let me try a different problem. So you're gonna have x to the power of 4, 3x to the power of 4 plus 4y to the power of 2 plus minus 7 minus 17 equals 21. minus 71 equals 21. 21. So you're gonna have this one. We're gonna have this one formula like x squared s to the power s cubed minus 3y plus 7 equals 23. So, this is called quadratic formula, quadratic formula, but they have a root here. But these two formulas are, as okay, you have, no, you don't. You have, no, you don't. So you're gonna have 3x squared. So the problem is you're gonna have 3x squared, 3x to the power of 4 plus 4y to the power of 2 plus 17 equals 21. X cubed plus 3y squared. See that this is 2 squared, this 2 polynomial terms squared, 4x plus 7 equals 23. So you can understand that this is a growth factor, and growth factor is a form. So how you identify power in the framework is you have this kind of problems that are square, quadratic, the shear quadratic term, or the shear binomial term, or the shear some kind of structure you try to identify. But the structure is basically where you the shape of the problem you identify. So basically you have every pathway, shape, or form of the calculus system. So you're gonna have this one. So let me try to do this one. So you're gonna have times by the power times by the power times by the power minus one for the power minus 1 for the power times by the old power. Okay, so so you're gonna have that system for derivative. You're gonna have the whole integration. You're gonna take two derivatives. You're gonna have so you're gonna have divided by the to take the integration. You're gonna add 1 to the power and divide by the base. Divided by the base. I think that's how it works. Add 1 to the power. Yeah, we have to flip it. I think I'm doing it wrong, but because I haven't done integration in a long time, but I know the derivative is right. So, add by the power. Add 1 to no wait. Add 1 to the power. Yes, add 1 to the power divided by the base. Is that right? I think so. So the first derivative I'm going to take is 3x squared. Let's make this English first. So to integrate 3x squared, you're gonna have 3x cubed 30 to the power 4. So add by the power, add 1 to the power, 3x to the power plus 1 will be 5. Add 1, divide by the power, divide by. So you're gonna have no, you're gonna have divided by the power, and add 1 to the old power. Basically, let me just find 1 second. 1 second, guys. 1 second, guys. So you're gonna have basically I'm back now. So you're gonna have 3x squared. You're gonna have so you're gonna have divided by the power. So you're gonna have the integration b with respect to x. 3x add 1 to the power, and divided by that's 3 to the power 5 minus 1 from the base. 3x to the power 5 minus 1 from the base. Divided by 3 to the power 5 divided by 3 to the power 5, and then divided by 5. This 3x 3 to the power 5 so we got 3 to the power 5 3x to the power 5 divided by 5. Obviously, divided by 5. You're gonna have 3x to the power 5 divided by 5. So derivative of is basically add 1 to so the root of 3x squared or dx is basically 3/5 of x to the power 5. So you're gonna have 3 divided by 5 x to the power 5 because you have to add 1 to the power and divide by the new power. So you're gonna have that 3/5 of x. And you're gonna have minus 4y. You're gonna have 4y squared. You're gonna have the first derivative b. Add 1 to the power, 4 to the power of 2, 4 divided by 2 is 3, 4 to the power of 3 and 4y divided by 3, usually also going to 4y squared. Uh, 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 no, sorry, so you're gonna have a 4y. We're gonna add 1 to the power and divide by. Basically, you're gonna have 4y to the power. I don't know. I'm gonna answer here. So the what's usual about 17. Y is constant. Y is not constant. Oh, yeah. So you're gonna have 4y squared because you're gonna have 4 to the power. You're gonna have add 1 to the power, 4y to the power of 3, y to the power of 3. And y to the power of 3 is 4y to the power of 3, or 4 divided by 3. 4 divided by 3y, because y to the power of 3. But this integration, use the area of the integration. So you have the 4, y to the power of 3, I believe. Y to the power of 2. But that's the first derivative. So you're going to have that will be the first derivative. And you're going to have the second derivative. So uh, uh, um, um, yeah, so you're gonna have uh, uh, so it allows you to take 5 double integration. You're gonna have double integration. So you're gonna have two. So basically, double integration have two ways to do. You're gonna have x and y. You're gonna have y and x and y. X. So respect to x and y. We can have a double of y. By being a double of y, you can have two integrals into one system. So so I'm gonna take the integrals twice. So you're gonna have it doesn't matter how much you do it. The this was gonna have 3x 3 in respect to x. You're gonna have respect to x and y. You have 3 fifth of x to the power 5, 4y cubed squared of 4 divided by 3 y cubed plus minus 17 minus c equals 21 minus c plus c equals 21. But C is 17, please 17, no, minus C is 17. You're gonna have minus 17. So minus 17 will be on one side. So, 21 plus 17 will be 36, 36, 36. So you're gonna get the third root of b 3 over 5x to the power of 5 minus 4y cubed 4 minus plus 4y divided by 3 y squared equals 38, 38. So this is the first derivative, the first integration. Now the first integration has a second integration. So you're gonna have 3 divided by 5. So you're gonna have the second integration, but you're going to have the system have a respective to system. So this is one of the pole or the axis of the poles, x to y. There's integration metric that was in sum. But you're gonna have to trace the derivatives. You're gonna have the derivative function of the system until the system collapses into one system. But it's gonna be a derivative of space and time, space in a sense. Same. So my alarm is finished now. Let me just start to pack up. But if I derive again, if I have now an equation, so this kind of thing represents kind of a polar Lapis framework. I'm trying to say, because it works on lambda. So you got a certain reduction. So you got alpha reduction. The one the most degree. So you got alpha reduction. If I have something with the most reduction, I can reduce the problem to one step. I don't have to. I can consider. I can switch context. I can just do that. It doesn't matter whether it's a determinant or a system. Having a Lapis framework is important because you have to determine what is so you have a functor framework. So functor frameworks, Lapis allows you to separate things that consume energy and things that actually are energy in STEM. So that's what I'm saying. Doesn't matter whether you're doing science or mathematics, you separate, you start to have a clear picture of what is done based on how you trace the derivative of the function. Thank you guys for watching the video. Let me show you the board now. So this is the board here. So it's saying, so you can see this, guys. So you can see it's kind of more blurry, but let's say I did the work two lapis here. Two lapis here, two derivative here. But it goes to have the system, no coherent. The more you do it, the more better you get to the same. But you're gonna have what is power and what is work. So you can separate the system and find something that's basically it's about efficient energy. Thank you, model.